morning. Today I will be discussing about series solution of Legendre's differential equation. Okay. I will be discussing about series solution of Legendre's differential equation. That is also a model question paper problem. It's also a model question paper problem. So series solution of Legendre's differential equation. So we have here the Legendre's differential equation, that is 1 minus x squared into d squared y by dx squared minus 2x dy by dx plus n into n plus 1 into y equals 0. So this is Legendre's differential equation. This is a model question paper problem. The question is there in the model question paper. They'll give the question as find the series solution of Legendre's differential equation. So first you have to write Legendre's differential equation, that is 1 minus x squared into d squared y by dx squared minus 2x dy by dx, okay, plus n into n plus 1 of y equals 0. N into n plus 1 of y equals 0. This is Legendre's differential equation. Now you have to find the solution of this. Now here the coefficient of y double dash, that is d squared y by dx squared is 1 minus x squared. That is equal to p naught of x. The coefficient of y double dash, that is d squared y by dx squared, is 1 minus x squared, and that is p naught of x. And clearly here p naught of x is not equal to 0. P naught of x is not equal to 0 at x equals 0. P naught of x is not equal to 0 at x equals 0. Okay. Now we use the power series method to solve this equation. We use the power series method to solve this equation. Okay. We use the power series method to solve this equation because p naught of x not equal to 0. Again I repeat, those who have come late. So the question is a model question paper problem. The question will be like this: find the series solution of the Legendre's differential equation. Find the series solution of the Legendre's differential equation. So the Legendre's differential equation is 1 minus x squared into d squared y by dx squared minus 2x dy by dx plus n into n plus 1 of y equals 0. Take it as 1. This is Legendre's differential equation. Then the coefficient of y double dash, this is coefficient of y double dash, that is 1 minus x squared, is always taken as p naught of x. You know, from in the previous session also we have solved for Bessel's differential equation, same method. But there, when x equals 0, we got p naught of x as 0. If you remember Bessel's differential equation, when x equals 0, you got p naught of x as 0. But here, when x equals 0, p naught of x is not equal to 0. So p naught of x not equal to 0 at x equals 0. We use power series method to solve this equation. We use power series method to solve this equation. Okay, we use power series method to solve this equation. We assume the series solution of 1 in the form sigma y is equal to sigma r is equal to 0 to infinity ar x power r. So we use power series method. P naught of x not equal to 0 at x, because if you put here 0, this will be 1, not equal to 0 at x equals 0. So we use power series method to solve this equation. So we assume the series solution of 1. The series solution of 1 as y equals sigma r is equal to 0 to infinity ar into x power r. We assume the series solution of 1 in the form y equals sigma r is equal to 0 to infinity ar into x power r. Okay, I will take it as equation 2. Okay. Now I have to substitute, since this is a solution, it satisfies the equation. I have to substitute it in d squared y by dx squared. I have to substitute it in dy by dx, etc. All these things I have to substitute. So for that reason I can write it as here. First I will find dy by dx from this. So dy by dx, how to find? Sigma r is equal to 0 to infinity ar. Sigma r is equal to 0 to infinity r is constant. Differentiation of x power r is r into x power r minus 1. Differentiation of x power r is r into x power r minus 1. And d squared y by dx squared will be sigma r is equal to 0 to infinity ar into r. Differentiation of x power r minus 1 will be r minus 1 into x power r minus 2. So this you know. Same thing done for Bessel's also. So once again I repeat, because the P naught of x, because P naught of x is not equal to 0 at x equals 0, we use power series method to solve this. Okay, so we assume the series solution of this Legendre's equation 1 in the form power series y equals sigma r is equal to 0 to infinity ar into x power r. We take it as 2, equation 2. Okay, now since it is a solution, it satisfies the equation. Since it is a solution, it satisfies the equation. So we have to substitute the value of dy by dx here, d squared by dx squared and y. So we differentiate with respect to x, that is dy by dx. Sigma r is equal to 0 to infinity ar, that is a constant. Then differentiation of x power r is r into x power r minus 1. Then I want d squared by dx squared. So d squared by dx squared is equal to sigma r is equal to 0 to infinity ar. We differentiate this into r. Differentiation of x power r minus 1 will be r minus 1 into x power r minus 2. Now we put all these values in 1 here in this. We put d squared by d squared value, we put dy by dx value, etc. See. So 1 minus x squared into d squared by dx squared. They written this. You can see minus 2x into dy by dx. So minus 2x into dy by dx value is written. Then plus n into n plus 1 into y. Y is this value, plus n into n plus 1 into y. Okay. This I think is clear with you. Okay, till so much you might get first 1 or 2 marks if you have done it correctly. Okay. Now we try to simplify this. So how? All the x terms can be multiplied. So what happens? First I multiply for this one. So as it is, when I multiply 1 into anything is same thing. So sigma r is equal to 0 to infinity r into r minus 1 x power r minus 2. Okay. Then minus. When you multiply here, x power r minus 2 into plus 2, x power r minus 2 into plus 2, you will get x power r. So I'll get, when I multiply this x power 2 and x power r minus 2, a power m into a power n m plus n. So r minus 2 plus 2, that is r. So I'll get minus sigma r is equal to 0 to infinity r into r minus 1. So x power r. So then here, minus 2x. So minus sigma r is equal to 0 to infinity x power r minus 1 into x power 1, that is x power r. Minus sigma r is equal to 0 to infinity 2 into ar into r into x power r. 2 into ar into r into x power r plus n into n plus 1 is sigma r is equal to 0 to infinity ar into x power r. N into n plus 1 will be sigma r is equal to 0 to infinity ar into sigma r is equal to 0 to infinity ar into x power r. Hope it is clear. So once again I repeat. See, now after substituting this, our aim is to multiply this. So what we get? 1. So we get here 1. When you multiply 1, it is the same thing. So what we get here? ar into sigma r is equal to 0 to infinity ar into r minus 1. This x power r minus 2 into this same term. Then minus, plus into minus, minus. Here when you multiply x power r minus 2 and x power 2, that is r minus 2 plus 2, so it will be x power r. Sigma r is equal to 0 to infinity ar into r minus 1 into x power r. Minus 2 minus sigma r is equal to 0 to infinity x power r minus 1 plus 1, that is x power r. 2 into ar into r into x power r minus 2 into like that, plus n into n plus 1, sigma r is equal to 0 to infinity r x power r equals 0. Now we equate the coefficients of various powers of x to 0. After this step, we equate the coefficients of various powers of x to 0. That is, I told you, even in Bessel's differential equation, when we found out its series solution, there also we equated the coefficients of different powers of x. But it depends. If the coefficient of different powers of x is 0 or not defined, we don't take it. So we start with the lowest coefficient of x, where lowest powers of x, where the coefficients are properly defined. In this case, what happens? First we equate to when r equals 0. When r equals 0, this will be a naught. This will be completely 0. So when if we first equate x power minus 2 means what happens here, and x power minus 1. So here we get, when we equate x power minus 2 means the lowest power, x power minus r is 0. So if r is 0, what we get here? If r is 0, we get here coefficient of x power minus 2 will be when r is 0, not this here. Coefficient of x power minus 2 when r is 0 will be a naught, r is 0, so 0 into minus 1 into x power minus 2. That only I wrote, a naught into 0 into minus 1. And on the right hand side, equating the coefficient means both left hand side and right hand side. In the right hand side, everything is 0. Again, I'm repeating. We equate the coefficients of various powers of x to 0. We equate the coefficients of various powers of x to 0. We start with the lowest. That is when r is 0, we get x power minus 2. Okay. So when r is 0, what happens here? A naught, this will be 0. Then this is 0 minus 1 is minus 1. So x power minus 2. That is the coefficient of x power minus 2. A naught 0 minus 1. Hope it is clear. A naught 0 minus 1. X power minus, that is a coefficient. So written here, that is equal. Right hand side always 0. But a naught is, which implies here 0 is already there. 0 is already there. 0 into anything is 0. So a naught is not equal to 0. A naught is not equal. This shows that a naught is not equal to 0, because even if a naught not equal to 0, the given term will be equal to 0. Even if a naught not equal to 0, the given term will be equal to 0. So here a naught not equal to 0. Then we equate for the next highest power, that is x power minus 1. If you want x power minus 1, here x power minus 1 is not there. Only here if I put r equals 1. If I put r equals 1, I get x power minus 1. So if I put r equals minus 1, a minus 1, r minus 1, minus 1, minus 1 is minus 2. If I put r equals 1, I will get minus 1, is it not? 1 minus 2 minus 1. So x power minus 1, equating coefficient of x power minus 1, I will put r equals 1. So a1, 1, 1 minus 1 is 0. That is written here. a1, 1, 0. And right hand side, all terms are zeros. Again here, there is a 0 here. So even if a1 not equal to 0, this condition is satisfied. So a naught, very clearly we come to the conclusion that a naught not equal to 0 and a1 not equal to 0. Come to the conclusion that a naught not equal to 0 and a1 not equal to 0. Okay. Now we equate the coefficient of x power r. Now we equate the coefficient of x power r. Okay. Now we equate the coefficient of x power r, that is r greater than or equal to 0. Now we equate the coefficient of x power r, that is r greater than or equal to 0. R is positive. If it is negative, then it will be like x power minus 1 and minus 2. So we equate the coefficient of x power r greater than or equal to 0. Okay. When we equate the coefficient of x power r to 0, when this will be x power r? This will be x power r when r is equal to r plus 2. Because r plus 2 minus 2 get cancels. This will be x power r when r is taken as r plus 2. So a r plus 2, r plus 2, r plus 2 minus 1, r plus 1. A r plus 2, r plus 2, r plus 1. Then here, coefficient of x power r as it is, a r into r minus 1, minus a r into r minus 1. Then coefficient of x power here, minus 2 into a r into r, minus 2 into a r into r. Then coefficient of x power r here, n into n plus 1 into a r, n into n plus 1 into a r. N into n plus 1 into a r. There, n into n plus 1 into a r. So equating the coefficient of x power r to 0, and right hand side is always 0. You know that. Right hand side is always 0. So here we get a r plus 2 into r plus 2 into r plus 1 equals. Take everything to the right hand side. Take everything to the right hand side. We get a r into r minus 1 plus 2 into a r into r plus n into n plus 1 into a r. Okay. Now there AR is common. If we take AR common outside, I'll get R into R minus 1 plus 2R minus N into N plus 1. Okay. Now here we can write it as here this one. This one is as it is. Okay. From this I can find what is AR plus 2. We get a recurrence relation here. We can find what is the value of AR plus 2. So AR plus 2 will be equal to, this can be brought down, minus of n into minus I removed out, n into n plus 1. Then when I remove minus 1, you know this will be minus r squared, minus this will be r squared minus r plus r. So when you remove minus outside, it will be minus r squared minus r. Bracket. Very simple. It's a simple calculation but lengthy. That's all. It's a very simple calculation. Sit and work out. Write and do it. Write in the notes, again write it down, then only you'll be able to follow. Otherwise, not possible. You can't by heart it. It's a sure question because it's also one of the model question paper problem. So AR plus 2 is equal to minus of n into n plus 1 from here. This will be r squared, then minus r plus 2 plus r. But when minus sign is removed out, it will be n into n plus 1 minus r squared minus r divided by r plus 2 into r plus 1 into AR. Okay, into AR. We got from here. Okay. This is the important for us. This is taken as equation 3. Now, we put here different values for r. We put here different values for r. That is, we put r is equal to 0, 1, 2, and 3 and see what happens. When I put r equals 0, I'll get here. When I put r equals 0, I'll get here a2 in 3. This equation 3. When I put r is equal to 0 in 3, I get this will be 0 means a2 equals minus of n into n plus 1. This will be 0, this will be 0. Here 2 into 1, that is 2 into r is 0, a0. Okay. Then I put r as 1. If I put r as 1, I'll get 1 plus 2, 3. That is a3 is equal to minus of this r as 1. R as 1 means it will be minus 1, that is minus 2. So simplify it, you will get minus of n squared plus n minus 2 divided by 6 into r is 1, so a1. This can be factorized. This can be factorized and can be written as minus of n minus 1. You know how to factorize it. I hope all of you know how to factorize it. So minus of n minus 1 into n plus 2 divided by 6 into a1. Okay, so a3 I got in terms of a1, a2 I got in terms of a0. You can note here very carefully that a2 I got in terms of a0. When I put here r equals 0, I got a2. I got a2 in terms of a0. And if I want a3, I have to put r equals 1. I got a3 in terms of a1. I got a3 in terms of a1. Now I will find a4. To get a4, I should put r equals 2. To find a4 or to get a4, I should put r equals 2. So when I put r equals 2, minus of n into n plus 1 into r is 2 means minus 4 minus 2, that is minus 6. So it will be minus of n squared plus n minus 6 divided by r is 2. So if I put r as 2, 2 plus 2, 4, 2 plus 1, 3, 4 into 3, 12. Then r is, that is 8. So I'll get minus of, again factorizing this, you know how to factorize, n minus 2 into n plus 3, n minus 2 into n plus 3 divided by 12. Into a2 value I'll substitute here. See, because a2 is there, a2 is in terms of, we'll try to simplify as much as possible. So minus of n into, I put the a2 value minus of n into n plus 1 by 2 into a0. So simplifying this, I'll get minus into minus plus. I'll rearrange and write it n into n plus 1 into n minus 2 into n plus 3 divided by 24 into a0 I got. So you can notice here all the even things. See, a2 is in terms of a0. Even a4 is in terms of a0. But the odd, a3 in terms of a1, we'll see what happens to a5. So to get a5, I should put r equals 3. So if I put r equals 3, here in this r equals 3, I will get minus of n into n plus 1 minus 9 minus 3 minus 12. So I get the equation as like this. See, a5 minus of n squared plus n, put here r equals 3. This will be a3. So I put like that. So I'll get minus of n squared plus n minus 12 divided by 20. Minus of n squared plus n minus 12 divided by 20 of a3. Okay. Now I can factorize this. Minus of n minus 3 into n plus 4 divided by 20. What is the value of a3? a3 is minus of n minus 1 into n plus 2 by 6 into a1. I'll substitute here minus of n minus 1 into n plus 2 by 6 into a1. So I'll get plus, then I'm writing in some order, I'll get n minus 1 into n minus 1 into n plus 2, n minus 1 into n plus 2 into n minus 3 into n plus 4 divided by 120 a1. So very clearly you can notice here all the even terms are, you get all the even terms in terms of a0. See, a2 in terms of a0, a4 after simplifying in terms of a0. All the odd terms, see, first I got a3 in terms of a1 after simplifying, a5 in terms of a1 after simplifying. So we, after simplifying, we get in terms of, so even terms we get in terms of a naught, odd terms we get in terms of a1, and etc. This goes on. We will find only till 2 or 3 terms enough. Now we substitute these values of a naught, a1, a2, a3, a4, a5, etc. in the expanded form of 2. Expanded form of 2 is there, you'll see. Expanded form, the solution. Expanded form of 2. Where is it? The solution of the equation. See, y is equal to sigma r is equal to 0 to infinity ar into x power. We expand it. We expand. You know how to expand. Put r value. So that is y is equal to a naught when r is 0. A naught into x power 0. That is a naught into 1 is a naught when r equals 1. A1 into x, like that. Is till infinity. So the expanded form of 2 is y is equal to a naught plus a1x plus a2x squared plus a3x cubed plus a4x power 4 plus a5x power 5, like that. Okay. Now what happens here? We have seen once again I'm repeating, I told already, a2, a4, a6, etc. we get in terms of a naught. All the even terms we get in terms of a naught. See, a2 in terms of a naught, a4 in terms of a naught, like that. And odd terms, a3 in terms of a1, a5 in terms of a1, like that. Since constants a2, a4 are in terms of a naught, there are two categories here. The constants even terms a2, a4, etc. are in terms of a naught, and the odd terms are what? A3, A5, A6, A7, etc. in terms of A1. We rearrange the RHS of this. We rearrange this Y in such a way that all the even terms are together and all the odd terms are together. Just we rearrange. So how? A naught even I wrote. Then comes A2x squared. Then comes A4x power 4 plus dot 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 plus. Then I write the odd terms. Odd term starts with A1x plus a3x cubed plus a3x cubed plus a4 not a5x power 5 plus dot dot dot, like that. 2 3 terms enough. Now I substitute the value of a2, a4, a3, a5, etc. here wherever in its place. Okay, a naught is as it is. A2 value I substitute. What is the A2 value? A2 value minus of n minus 1 into n plus 2 by 6 into a1. So here I write it, minus of n into n plus 1, see a2 into x squared, minus of n into n plus 1, a2. See, minus of n minus 1 into n plus 2 divided by 6, okay. So a2 is minus of n into n plus 1 divided by 2 into a naught. So minus of n into n plus 1 divided by 2 into a naught. That 2 I wrote it as 2 factorial. That is to get a pattern in the formula. Then comes a4 plus a4 x power 4, I wrote a4. A4 values here, n into n plus 1 into n minus 2 into n plus 3 by 24 into a naught. So that I wrote, but 24 is nothing but 4 factorial. 4 into 3, 12, 12 into 2, 24. Like that, it goes on. We did not write everything in this, okay. Next we come to this a1, okay, a1. So everything is in terms of a1, so a1 I wrote outside into x. Then a3 here is minus of n minus 1 into n plus 2 by 6 into a1. So minus of n plus 1 by n plus 2 by 6 into a1 is written here x cubed, but 6 can be written as 3 factorial because 3 into 2 is 6. 6 can be written as 3 factorial because 3 into 2 is 6. I hope it is clear. Okay, it is clear. 6 because 6 is 3 factorial. Then so a3x cubed, then a5x power 5 here, a5x power 5. What is the value of a5? That is n minus 1 into n plus 2 into n minus 3 by n plus 4 into 120 into a1. So a5 value I wrote. But 120 is nothing but 5 factorial. N minus 1 into n plus 2, n minus n plus 4, n minus 1 into n minus 2 into n minus 3 into n plus 4 divided by 120. 120 is 5 factorial x power 5. So plus minus like that. Now what we do, these terms I take as u of x and these terms I take as v of x. These terms I will take as u of x, these terms I will take as v of x. So let u of x and v of x respectively represent the two infinite series in 4. This infinite series I'll take as u of x, this infinite series I'll take as v of x. In 4 I substitute, so I'll get y is equal to a naught into u of x plus a1 into v of x, where u of x and v of x are infinite series. So this is the This is the series solution of Legendre's differential equation. This is the series solution of Legendre's differential equation. So this is a model question paper problem, very important. So once again, I will just recall this. I'll just revise a little bit faster. See now here. Okay, series solution of the question will come. Give the series solution of Legendre's differential equation. It is there in the model question paper. You can just see that. Okay. Now we have Legendre's differential equation. This you have to by heart. 1 minus x squared d squared by dx squared minus 2x dy by dx plus n into n plus 1 of y. Here clearly p naught of x, that is the coefficient of y double dash 1 minus x squared. P naught of 0 is not equal to 0 at x equals 0. So it has got a power series solution. We take y is equal to sigma r is equal to 0 to infinity a r x power r, taken as equation 2 as the solution of this. Once it is a solution, it satisfies the equation. So here you find dy by dx and d squared by dx squared and substitute it in 1 and y also. And then multiplying, arranging and all these very simple things I have explained. I have also written it very clearly, expanding it. You write in the notes properly. After you have written it properly and written it as different powers of x, then equate the coefficient of various powers of x to 0, starting with the lowest. Lowest means here when r is 0, it is x power minus 2. Put r equals 0, you get a naught into 0 into minus 1. Right hand side is always 0. So here clearly we can make out, even if a naught not equal to 0, the equation is satisfied. So a naught not equal to 0. Next is coefficient of x power minus 1. So coefficient of x power minus 1 means put r equals 1. So we get a1 into 1 into 0 equals 0. So clearly a1 not equal to 0. Now we equate the coefficient of x power r. Now we equate the coefficient of x power r. That is, next we take x power r greater than or equal to 0. We get like this from here. X power r. Coefficient of x power r means here I would write r plus 2. So plus 2 minus 2 cancel. We get r x power r. So a r plus 2, r plus 2, r plus 2 minus 1 is r plus 1. A of r plus 2, r plus 2 into r plus 1. Here as it is a minus of r into r minus 1. Here minus 2ar into r as it is. Here plus n into n plus 1 into ar. Okay. Coefficient you got from that, we find out ar plus 2. It's very simple. Find ar plus 2 in terms of keep ar plus 2 one side, remaining simplify, take to the other side. Then put the values for r 0, 1, 2, 3. When you put 0, you will get a2, you will get like this. Simplify. Then put r equals 1, you will get a3. You get a3 in terms of a1 like this. Okay. So minus n plus 1 by 6 into. So you got a2 in terms of a0, a3 in terms of a1. Then if you want a4, put r equals 2. So if I put r equals 2, I get like this. And then put this a2 value, get like this. So you get all the even terms in terms of a0. And for a5, I'll put r equals 3, I will get like this. I'll get like this. So then put this a3 value. A3 value is here. Put the value. You will get it as in terms of a1. So all the even terms, a2, a4 ends with a0 or in terms of a0. All the odd, a3 in terms of a1, a5 in terms of a1. So taking that into consideration, now we expand equation to the power series solution. Y is equal to a0 plus a1x plus a2x squared plus a3x cubed plus a power x power 4 plus a power 5x power 5, etc. Now since a2, a4 is in terms of a0, a3, a1, a3, etc. is in terms of a1, we split this and write all the even terms together and all the odd terms together. So a0 plus a2x squared plus a power 4x power 4 plus a1x plus a3x cubed, etc. And substitute the values of a0, a1, a0 as it is, a2, a3, a4, etc. Substitute it. We get one terms in terms of a0, another in terms of a1. So there are two parts in this. We take the first infinite series, this one as u of x, and second infinite series as v of x. So y can be written as a0 into u of x plus a1 into v of x. So this is the required series solution. This is the required series solution of Legendre's differential equation. So I explained it 2 times. Now this is a very important, at the end of the session I would like to summarize. Today I derived Legendre's module 4. In that, the second part, series solution of differential equations, I derived Legendre's differential equation. 2 sessions back I derived Bessel's differential equation. Even that is there in the model question paper. Even this is there in the model question paper. Please write the notes. Yesterday I derived some other part. Is it not? Yesterday I derived. That is the orthogonal condition. Orthogonal conditions I derived when alpha not equal to beta. That is also a model question paper problem. So 3 classes I have derived 3 derivations of model question paper. So all of you write the notes, solve assignment 1, that is A1 given in the class, and write and study. Always write and study, it will be easier. Still any doubt is there, please ask me, contact me, or when the college starts you can ask. So keep working. I wind up here, wind up the session here. All the best. Thank you.